Hello, and thank you for tuning in today. I'm excited to be speaking at the Adversary Village as part of the 2021 Texas Cyber Summit. My topic today is assume breach penetration testing at a cloud native organization. About 6 months ago, I joined a tech startup, Gatsby, and my experiences from doing internal pen testing at Gatsby are very much the basis of this talk. So, what is Gatsby? What do we do? Gatsby is both an open source web technology stack and a cloud platform. The Gatsby framework is an open source React Jamstack framework for developing optimized static and dynamic websites. The Gatsby cloud is the commercial side of the business, and it's a cloud platform to build, preview, and deploy Gatsby developed websites on a super fast edge network. We are a heavily cloud-driven company with 100% of our staff working remotely around the world and have no on-premises network. And as you can expect, this would present some challenges in pen testing. My goal today is to provide you a method of approaching a better pen test in a heavy cloud environment. A quick background about who I am. I'm Mike Gualtieri. I've been in software and cybersecurity for a bit more than 2 decades, wearing both business and technical hats throughout my career, often at the same time. Earlier this year, like I just mentioned, I took on a new role as a staff security engineer at Gatsby, where I'm formalizing and building out our security and compliance program. I get to have my hand in everything from pen testing to detection engineering to vulnerability management to risk analysis to implementing our SOC 2 compliance and everything in between there. So it's a big job, and I have to say I love it. It's a lot of fun. In addition to my role at Gatsby, I'm on the part-time faculty at the University of Pittsburgh School of Computing and Information, and specifically I teach for a program called the Professional Institute. I developed and teach 2 courses for the Professional Institute called the Offensive Boot Camps 1 and 2. And those courses teach students vulnerability analysis and penetration testing. Prior to Gatsby, I spent 15 years as an entrepreneur where I ran a software design and development firm. I was the principal consultant of an offensive security firm and founded a children's technology company built on Linux and open source technologies. All right, let's get the real content here kicked off. If you aren't familiar with the term assume breach, what do I mean when I say it? Essentially, assume breach is a penetration testing methodology where non-administrative access to compute resources are provided to the tester ahead of time. In a traditional setting, think domain user or domain workstation access. I'm a big fan of assume breach pen testing. I've actually spoke about it a number of times in other contexts over the years. In my opinion, assume breach is by far the most efficient way to uncover security issues at an organization. It beats the pants off other approaches, especially black box external tests. Why? Because it saves time, it saves cost, and it delivers more value to the client. One big key to assume breach is that the more realistic the access provided, the better. It needs to mimic the access that would be gained through that initial breach. So it needs to mimic that initial phishing link clicked. It needs to mimic a successful remote command or code execution on a target. And then once breached, what is that system? Where would that adversary be and in what context? That's your starting off point. On a traditional on-premises network, what I've done in the past is when I was a consultant, I would have an account set up like it would be set up for a typical new employee. Or even better, if I could do it, was to use a former employee's account for the duration of the test, because there might be deeper permission links on an old account that the simulated account might not actually have been added to. I've actually started off tests using current employee accounts as well, because we all know an employee starts off with a set of access, but to do their job, they need permissions added to another half dozen systems. Oh, and actually, to do this one thing on that in-house developed system, they actually need administrative access to that system. And that list keeps growing, right? You've probably seen this before, especially if you worked in IT over the years. How is the access provided, though, to the penetration tester? Ideally, somewhere remote, some way you can do this remote to the network, especially after COVID. Remote can either be a VPN or a Citrix login, whatever the typical employee would have access to. Or even better, you can supply the target with a pen test Dropbox to securely enable that remote connection into or out of the target's network into some type of command and control infrastructure. But this only makes sense for traditional on-premises networks. If your target has no organizational network, you need to think about how to react, how to provide access and where to provide access. This is a topic we're going to be exploring today. But first, I made a claim in the previous slide that assume breach saves time, it saves money, and increases value. And you could take my word at face value, but I'd like to illustrate my point with an example. So here we have a locked box, and the penetration tester's goal is to get inside this box. And unfortunately for a penetration tester, even though he or she is really, really good at their job, they just couldn't get inside that box. They found a couple nicks in the side of the box that could maybe help somebody figure out what was inside the box, but the box just remained closed. Unfortunately for the owner of the box, an adversary found a key to the box in a neighbor's house. And that's a place the pen tester just didn't think of looking, or probably more likely, it's a place that they didn't have permission to look inside of. Once that box popped open, there we go. All the goodies inside came out, much to the joy of the adversary and much to the disdain of the owner of the box and much to the frustration of the tester, because they wanted to do a more thorough job. They just weren't able to. You can see from my colorful example of the goodies that are found once inside this locked box. Once this locked box is opened, it's full of presents. There's more keys to other interesting things and other things that, if the tester saw it, the report would probably be sure to be full of findings. So do yourself an advantage. Give the tester that key to the box before the key is found elsewhere, and then find out what deeper problems exist inside. Now, before we dive into the cloud portion of the talk, I want to take a step back for a moment and break down how a typical assume breach test works. So I know that not everybody watching this is a penetration tester. So I'm going to break things down how it works step by step. This is a representation of a typical on-premises Active Directory environment. Our tester sets up and is connected to an initial point of access. Let's just call it workstation WS01, and they're logged in as the user org/staff01. Maybe credentials are supplied, maybe not. I usually prefer to have these supplied, but it works either way. Once some situational awareness is gathered, our tester will attempt to begin lateral movement opportunities. Some of these require network access, some require a network login, and some require administrative access to some type of computing resource. I've listed things out below in various buckets. And I don't want to spend too much time on this because it's not really the focus of the talk, but I do want to go through each of these because I think it's a good example of how a typical on-prem penetration test will go. All right, so attacks that require just network access are things like just doing some network reconnaissance. You can do port scanning, see what's out there on the network, exploit flaws on systems that you find, conducting phishing to gain that initial domain user access. You can do default credential abuse. And in this bucket, think about printers and devices that maybe will write to SMB shares. You can conduct network sniffing. And you can do network-based lateral movement and credential harvesting opportunities. And by that, I mean things like, if you've heard of tools like Responder, NTLM Relay X, Man in the Middle 6, doing things like passing the hash. These are all ways to elevate access to a domain context. The next bucket requires that you have domain user access. And this is actually the more interesting bucket, right? And here we do some basic domain and reconnaissance. We can explore network and file shares for anything interesting, like passwords.xls, right? You can use a tool called Bloodhound, which is an awesome tool if you haven't ever used it. And it's a tool that maps Active Directory permissions and ways to move laterally around the network through them. You can do curb roasting. You can do Active Directory delegation attacks. There's usually some goodies in the sysfile volume, scripts and GPP passwords. There could be privilege escalation on the current target if you aren't administrator already. And there's network-based lateral file movement, just like how we have discussed in the previous bucket. The final bucket here requires local admin access to a domain computing resource, so like a workstation or server. Once you have that domain admin access, not domain admin access, local admin access, you can do things like dumping credentials you can use Mimikatz or any method of dumping credentials. And you can do Active Directory lateral movement techniques that will require some type of local admin access. And there's always post-exploitation, right? We're gaining more credentials. And as we gain more credentials, we look for what those credentials can access. And that kind of lateral movement moves in a circle all the way till we get to our goal. Now, I should note that there's nothing too special in this description that deviates from just what a general pen test would be, just the initial access, right? It's assumed breach because we're setting up the tester on WS01 logged in as staff01. So this would simulate a successful phishing attack, which would drop the adversary into the domain user context. But if you wanted to test assumed breach in another way, like a compromised website or network device, you may be able to change that initial point of access to something like a Linux shell or something similar that mimics that breach device. The process, though, afterwards remains pretty much similar for most organizations. But unfortunately, this model has some problems when targeting a cloud-native organization, which we'll explore in a few minutes. So on to our next topic. What do I mean by a cloud-native organization? Besides cloud-native being a buzzword, what I would define it as is this: an organization that relies on platform as a service vendors for the majority of their computing resources. And I'm sure there's some of you out there that would dispute this definition, and that's okay. And there's definitely nuances between what cloud is and a hybrid cloud and a company that maybe uses container technologies like Kubernetes within their on-premises network and non-cloud data centers. And that's okay. Don't worry. You are all welcome at the table today. A lot of what we'll discuss will be useful for organizations that operate in a heavy cloud environment or maybe have a hybrid on-prem, on-cloud network. My goal today is to provide a lens, especially for scoping, for testers who come against an organization with this type of heavy cloud environment. And as I hinted a few times already, targeting a cloud-native organization has some problems. Namely, that whole lateral movement section I showed you a couple slides ago is completely out the window. And that's typically where all the magic happens in a penetration test. So our problems include there might not be any on-premises network. And this is a big one because it completely neuters the ability to move laterally between computing resources and users. This is where credentials are typically gathered and more resources and access is gained. Next, many or all devices may be bring your own device. This is another big one because a typical employee device probably doesn't have access to any additional computing resources. And without access to resources, lateral movement opportunities are essentially non-existent. Third, a typical employee account may not have access to any resources that would help us to get to any testing goal. And what is a typical employee account anyways in this environment? Their email login? Does their email login get you to the internal administrative system they requested as a testing goal? Maybe, but what value are you providing as a tester? They already know if you trick an employee to click on a phishing email and you manage to get their two-factor authentication token, you can access systems that require a login with these credentials. Is demonstrating that really proving enough value to the client? And again, maybe you can demonstrate that a phish would bypass some of their defenses, like their EDR setup, their network monitoring, and that can be valuable. But I would also argue that's better handled in a purple team exercise than a penetration test. But my point is, if access is given to a typical employee account, that employee has login rights to the testing goal, then the test is kind of over and it didn't provide anything of value that the organization didn't already know. And if the access to the account provided doesn't even have login access to that system, it's less likely there's going to be a lateral movement opportunity in this environment to get you to that testing goal. So just want to stop for a second, digest that, make sure everybody's following me here, right? Because this is a point that I want to make. It's hard to do the lateral movement in this environment to get to the goal. The last item on the list isn't necessarily a problem, but it's one that's a little different than a typical Active Directory network. Authentication to systems will happen by one or more of the following options: a username and a password, and hopefully also some type of two-factor authentication token. It can also happen through a single sign-on provider. So anything that's SAML, right? Google, Auth0, Okta, Duo, Jump Cloud, there's a bunch more. And maybe in addition to that single sign-on, they might even require an additional two-factor authentication token to some systems. You're also likely to encounter some sort of password vault with shared account access, because some services are less expensive to share logins for. And last, and certainly not least, are access tokens. These are great. An access token is one that provides access to an account without a username or password or two-factor authentication. The reason being is because the token represents that you're already logged into that resource. Today, we're going to be looking at this hypothetical cloud-native organization. My examples today will be more focused on Google Compute Cloud, GCP, but should translate well to any other cloud provider, since they mostly provide the same services between them. So I've mostly worked with GCP and AWS, and I think my examples will pretty much translate between both those environments. Employees will have access to some portion of these compute resources. Marketing, for example, will be able to update the website. Integration developers will have access to those external apps and some internal apps that maybe communicate with those external apps. DevOps engineers will have access to the internal apps that you see in these two virtual private clouds, the VPCs, but not necessarily the external ones. And when I say internal app, I mean a containerized piece of software that's part of a microservices architecture. These microservices apps communicate via authenticated API connections, usually authenticated by some sort of token. Often it's a JWT or JSON Web Token or some other type of service account token. General business employees, though, will likely have access to none of these, except for maybe just some external business apps and email. So how do we approach this testing? That's the topic of the talk today, and it very much comes from my personal experience. I came up against this when planning how to approach our internal testing at Gatsby. Once I got our security program up and running, handled some initial priorities, I was given the green light to conduct internal penetration testing. I had the latitude to execute the test in any way I saw fit. I could choose my own testing goals that were, of course, impactful to the organization. I had unlimited scope and a timeline of my choosing. Gatsby was mainly interested in what I would come up with in this test. This should be a pen tester's dream, and I was excited, but also I sat back scratching my head how I would approach this test. I had a lot of insider knowledge on how our systems worked, but I needed to approach the test as an adversary. What would an adversary target? What is that attack surface? What are the most likely attacks on that surface? And what should I prioritize to test? So if you have one takeaway from this talk today, I really want you to think about scoping, which we'll discuss in a bit. And when you do, mix in some basic threat modeling. Doing this will benefit any penetration test, but it's much more important when approaching this sort of atypical organizational test. Let's briefly discuss methodology, and then I'm going to dig into each topic. First, set your goals. What is important data and where is this data located? This should happen for any pen test. Second, how do we get there? This is about understanding the architecture and topology of the organization. What happens behind the scenes when an employee gains access to a system? On this part of the planning, the more information that can be gathered about the architecture up front, the more efficient you'll be at tracking down goals. Now, you might say, well, an adversary won't have any access to this knowledge. Really? Well, what about insider threats? And what if an attacker gains initial access and just parks themselves unknown inside, observing for a few months? What if they just get lucky? The point of assumed breach is efficiency, but also assumed breach doesn't need to be a 100% open book test. It's not a white box penetration test. That's different. The tester should be forced to act like an adversary in certain situations like realism, for realism. For example, let's look at cloud storage bucket names. The adversary may be able to deduce an app interacts with the storage bucket, but has no permissions to list buckets in that system. Their only option then is to brute force bucket names. And if your bucket name is difficult to deduce, then there's little chance the attacker is going to be able to determine this. It's all entropy in this case. But also, an assumed breach test isn't a covert red team exercise, and there's some subjectivity on this. Maybe the tester reaches out and says, I think I could make some more progress towards this goal if I knew insert blank item here. Can you help me understand the piece I'm missing? And then it's up to the organization to determine if the tester should be given that information. Second, next, I should say, third is what is the attack surface? It's not realistic that an attacker upon initial breach should be able to gain access to certain portions of the network. Some applications may be completely unreachable unless achieving an IAM privilege escalation at the cloud provider. You need to look at the architecture and determine where could an attacker land if breaching that initial system. If an attacker found a remote code execution in an organization's website, what Kubernetes pod would they likely have access to and in what context? It's also a good idea to do some precursory open source intelligence at this stage. It's not always the case that organization will know their systems are out there, know all their systems out there, and may even think some of these systems are secret. Open source intelligence may determine some other good starting off points for the test that have maybe different contexts and levels of access. So I'm talking about things like old.website.com, dev.website.com, hidden API service.website.com. Finally, how can we get set up in a realistic manner at these locations? This is a highly application specific topic, but we'll discuss some real world examples later in this talk. But essentially, you want to provide convenient access to the tester in a manner that drops them into the same environment that would be gained after successful exploitation. I've also included as a tacked on item, what else should we analyze while testing? For example, it might be a great idea to run an assessment of privilege escalation vectors for all IAM members at the organization. An opportunity may not come up during testing to conduct this type of analysis, and the tester is available for their expertise. So it certainly could be a valuable exercise, even though it probably falls more in the vulnerability assessment category. All right, let's break down each of these steps in detail. First off, goals. Are you doing them? Yes, I hope. Everybody should nod their head. Yes. Every pen test should have goals associated. Let me repeat this. Every pen test should have goals associated. It's my strong opinion, not my humble opinion, that when you're conducting an organizational pen test, goals are a must. And goals should be impactful to the organization. Focus on accessing data or systems that would give the C-suite chills. Don't get into traps that are limited to technical achievements. You as a tester might be gleeful about breaking out of a Kubernetes pod and taking over a node, but does your audience paying for the test understand what this means? And by taking over a node, I mean, what data were you able to access? Why did it matter to the organization? What was the impact of this data leaking out? If taking over that application wasn't an explicit goal, where in the pen test story did this vulnerability fit? If your target doesn't have specific goals, and that's often the case, it's your job as a tester to help them determine these goals. Otherwise, how do we know if the test was successful or will make an impact enough so the remediation gets the prioritization it deserves? So today, for our hypothetical pen test on our hypothetical pen test organization, we're going to lay out some goals. So first is we're going to try to gain access to customer payment data. Second, we're going to gain access to an internal administrative system. Third, we're going to gain access to customer data from inside the application. And fourth, dump the users table from a production database. Our second step here, where the heck are the goals located? For a traditional pen test, it's often that a shared drive owned by a permission group or some type of internal database application will have the data that we're trying to access for the goal. For a cloud native organization, it's a lot more likely there's going to be some segmentation between you and that goal. So we'll use our previous knowledge of the organizational architecture to chart some likely paths. Let's look at the first goal, gaining access to customer payment data. The data itself happens to be located in Stripe and also displayed within the application within the user's account. But this also means that the data is present or at least travels through the Kubernetes pod that processes the user account data. And as it also turns out, our developers are actually pretty smart and they don't make the Stripe API connection from the public app that prepares data for the user's profile. Instead, they make it behind the scenes in a private app that retrieves the data from the Stripe account. Payment data is also present within the administrative application. So if we gain access to the admin app, which is another goal, we can gain access to the total payment data. Or perhaps all we need is access to a special API call that allows us to pull the data over for all users. By understanding where the data is present within the organization, we can better focus our attack. I'll just run through the rest of these goals quickly here. Our second goal, gain admin access to the system. And this is pretty straightforward. The admin system is located at internal.myorg.com, and it's available at the Kubernetes pod that processes the admin data in the public virtual private cloud. Third is access to customer data inside the application. So this data is stored obviously within the application, user profile payments, but that requires JWT authentication. It also travels through Kubernetes pod, user profile, star in the public VPC. And it's also available in the Google Kubernetes engine, the GKE nodes, at some type of unknown host name. We aren't sure. We weren't given that information. Goal 4, dump the users table from the production database. And this database connection actually originates from the private virtual private cloud. The data itself is stored in a Cloud SQL instance, and backups, we're told, are stored in a cloud storage bucket, but we don't know the name. Now that I've charted and kind of described all the locations, I've overlaid them on this network architecture that we previously put together. And it kind of looks like a mess, but it's all color-coded there where the different goals are. So this is how we can visualize our test. Now, I should note that the goals may be elsewhere in this diagram, and testing may demonstrate this. But at the very least, this diagram gives us a good picture of what areas of the organization to target to meet our testing goals. Now that we know where the data is located, what's the attack surface? How can we access this data? And what would be the most likely attacks? So let's break down each from the previous slide. So the goal of gaining access to customer payment data, well, it's obviously in Stripe. So if we can gain access to Stripe, we can get this data, right? So you could fish for a Stripe password and two-factor authentication token, but I really don't recommend that. A big word of caution is that you might not want to point phishing attacks at a platform as a service provider. It's maybe against their terms of service, and while criminals won't care, you should. But there's other ways to gain access, like obtaining a cookie for a logged in user. We can gain access to the Stripe access token that the application uses, and that might be present at environment variables. It might be in a secrets manager. It could have been committed to a Git repo. It could be inside the application source code, or it could be part of a Docker image. The next area where we can maybe gain access to this is within the application, and this would be via JWT, cookie, session manipulation. If we can change the session in our favor, we can gain access to new data. And finally, it's available in the infrastructure of the organization. So here we think about lateral movement to different pods in the Kubernetes infrastructure. We can take over a GKE node, or maybe we can gain access to an IAM member or service account that gives us more access. Similarly, with the second goal of internal access to the admin system, this happens in the application. We could phish an employee for a password and two-factor token. In this case, phishing is probably okay because you're testing the company, not an external platform, but you can choose how to go about this. You can also obtain a cookie from a logged in user, and again, the JWT cookie session manipulation. It's also available in an infrastructure if we can gain access to an IAM member or service account. Third is gaining access to the customer data from inside the application. So that can happen inside the application through API abuse, again, with the JWT or session manipulation. It can happen in an infrastructure. Again, really similar. We can break out of a pod. We can move laterally. We can take over a node. We can access this with a service account with higher privileges. And fourth is dumping the user's table from the production database. This can happen, again, through API abuse. Maybe we can just extract all the users by abusing an API call. We can gain access with a username and password. We can gain access to this maybe in an environment variable or in a secrets manager. It might be in the Git repo, source code, Docker images. And again, if we have access to a service account with privileges to access the database, then we can gain access. final step here is how do we get set up? And this is application specific, but one location for us in our hypothetical organization will be inside the Kubernetes pod that powers the user profile microservice for the web application. If there's data processing to and from this pod, we can maybe make a conjecture that it's possible for an adversary to gain access to the underlying pod and the data within. If any website of the company uses third-party JavaScript includes that aren't protected by a content security policy or sub-resource integrity, we could petition to inject a small piece of JavaScript code into the website and use that as a starting off point. One word of caution on this though, even if you gain approvals, be sure to use execution guardrails. Determine who and what you're going to target ahead of time as to not snare real world visitors and customers. A third opportunity would be to have some type of provision IAM access with roles granted similar to a typical employee or even better, a service account. Also, any resource that has that external attack surface. The IAM permissions grant essentially simulates an employee being phished, or like I said, even better scenario is a service account being breached within the infrastructure. How do we set this up determines if you're an internal tester or an external tester. If you're an internal tester organization, you may already have some level of access to these systems or can provide a temporary access to gain, or the temporary access can be provided to gain access to what you need to conduct a test. Access to Kubernetes pods is as simple as using kube control and exec into a representative pod. Although where possible, try to tie your access to the application layer. The goal isn't necessarily to exec into any pod. It's to exec into the pod that contains the data for the account that you're testing with. This way, you won't disturb customers using the company's systems, and you can test changes to that data. If you're an external tester, the best way to conduct testing is via a dedicated compute instance that's available via SSH. The login should provide access to kube control with a profile already configured with the correct credentials. You have the RBAC permission set up for pod exec to the pod or pods that have been made available for the duration of the test. It may also be nice to provide Kubernetes Git permission access to some of the resources like Git pods so the tester can navigate a bit more efficiently. This information would likely be readily available to any internal tester. The SSH account can also be configured for command line access to the G-Cloud or AWS APIs and can be set up with access to the service accounts that are to be tested. If using a JavaScript inject, then communications can be tunneled back to the same server via HTTPS. All right, so let's see some of this in action. We're going to run a kind of a simulation, a guided walkthrough of what I think are real world examples of what you may encounter. And we're basically going to go from 0 to hero on this. We're going to start off with kube control command that's going to exec us into, with a bash shell, into the user profile pod. So this pod is specific to the profile of the user that you're logged in with on the front end of the application. What you probably first want to do is conduct some type of situational awareness. So as luck would have it, we run ID and we find out we're logged in as root. Please ignore the dollar signs instead of the pound signs in front of my commands. It's only because if I put a pound sign, it's going to change how the colors look on the page. So just know we're root right now. Well, we probably want to see what's running on the pod. So the first thing we're going to do is maybe a PS AUX to see the processes and what's running. We're also going to run netstat if it's available. And the command's not found in this case. But as luck would have it, often if you have root access to a pod, you can start running updates. So we do an apt update, and then we can do apt install net tools, and we can run a net stat, and some output comes here. It shows us what processes and items are running on various ports. Next up, one thing you definitely want to check out is environment variables. This is often how access tokens are passed around in a very cloud heavy microservices environment. So here is our environment variables, and we see two that are kind of interesting. A few lines down, we have JWT equals and a long string that's a base 64 encoded string, and cookie equals another base 64 encoded string. So those are items I definitely want to take a bit more of a deeper look in a minute. Next, we are going to see if we can abuse the default service account. And if you've ever worked with GKE in a Google Compute Cloud, you will know that they've really locked down default service accounts and they have no access to anything. This is a popular way to move laterally in Kubernetes. It does not work in GKE, at least not by default. We're also going to try to see if we have any type of service account access. So this is done through the Google metadata service. And this is really similar in AWS where you're accessing that metadata service. But unfortunately, our host couldn't be resolved. So we're going to move back to those environment variables. We're going to unpack the JWT. And JWT is 3 sections. They have the header, which tells what type of signing is used. They have the payload, which is actually the content of JWT. And the third section is the signature. So we're going to unpack the first 2 sections. We see it's a JWT token. And we also get the information of this session. It has a user ID and a username. Great. We're also going to unpack that cookie. And we see that we have additional information. A cookie was sent, has user ID, email, some other data. So let's see how this cookie is used. Remember, the source code's on the machine. So we can grep through the source code, and we find this interesting routine called get payment data that takes use of that cookie and the JWT token. So if we pass data, we can analyze that function. It's basically the same thing, doing the same thing. It's making an API call, really similar to curl. So we'll just use curl so we can manipulate the data. And we can successfully get back our payment data for this user, right? Because that's their cookie, that's their JWT. So let's try to manipulate it. And we're going to try first time by just changing the UID, right? This is a popular thing. But unfortunately, when you change the user ID, you get back a 403. It's forbidden, user unauthorized. So there must be doing some level of checking with that JWT to make sure that the two match up. Attempt number 2. We're going to instead change the user ID and the version, right? I noticed that there was version 1.01. I wonder if there's a version 1.0, maybe with bugs in it. And as it turns out, in this case, it succeeded. And because of that, goal 1 is complete now. We can gain access to customer payment data that's not our own. Moving further, we're going to inspect the source code more, and we find a path deeper in the source code that actually has a Git repo that's embedded in it. We can use a utility called TruffleHog to analyze that Git repo to see if there's any juicy findings in there. And as it turns out, a while back, a developer committed .env.production to the Git repo with the database connect string. And we try to use these credentials for the MySQL that we know is out there, but it doesn't work. So they must have realized their error. They changed the connection string. Okay, that happens. We also find a secrets.yaml file, and this is part of the Kubernetes infrastructure. And we see something called a backup token. So that's kind of interesting. It must be another service account, and the cert is right there as well as the token. So we're going to go through and we are going to try to see what permissions that service has. So we're going to see pods. We're going to try to exec in the pods. We can list all the permissions. So we find out we do have exec access. So we exec into this interesting pod called authentication. In there, we find the JWT secret. This is the signing key. And inside the signing key, we can create tokens in any way we want now. And as it turns out, because we can manipulate the whole token, we can just change the user ID now to anything, and then we can log into any user in the system. And this checks off Goal number 3, gaining access to the customer data inside our application. We can log in as any customer now. It also checks off goal number 1. Again, we also attempt to do this with the admin portal, but it doesn't work because they're using another JWT. So let's continue on. A few more steps here. Kube control. We have access. We just explore different pods. We find a backup pod. And it turns out that this pod has access to a service account, which we can verify through this Google metadata service. So we installed G-Cloud utils right on the pod. And now we have access to G-Cloud and GSUtil. So we're going to try to list buckets, but we get an access denied. That's typical. So we'll brute force the bucket names. There's a million brute force tools out there. Let's just say we brute force names and find this interesting pod or interesting bucket called database backups. And in there has backups to the MySQL production database. Once we snag that, goal 4 is complete. We have a dump of the users table from the production database. Finally, we're going to try to also pull Docker containers. And it turns out we can list containers. We can download them. We're going to download one for the admin pod. And when we run into that, we're going to find out that this was the private admin pod and it had another JWT secret for forging the JWT access for the admin tool. We're going to do that. We're going to make another JWT. We're going to sign us up as admin ID 1, which we learned how the format of that JWT is from the source code in that Docker container. We load that into our browser, and now we have access to the internal administrative system as any administrative user. So goal 2 is complete. And that's pretty much it. I appreciate your time today. While we discussed assumed breach in a hypothetical cloud native organization, and especially some of the challenges that come about in terms of scoping this type of test. I hope for your takeaways, you can better scope out such a test to position yourself towards impactful goals and outcomes. If you want to get in touch with me, my website and Twitter handle are on the slide, and I'm always happy to connect with new and old people in security.